Hello everyone, welcome to another video for Mathematics of Grade 9. In this video, we are going to start section 6 of chapter 5, which is about proportions and measures. The goal of this lecture is to compare the perimeters and areas of two similar triangles. So if you remember from section 4 of this chapter, we talked about similar triangles. We are going to compare the perimeters of two similar triangles and as well as the areas of two similar triangles. But first we have to see the first definition here. The ratio of two corresponding sides of two similar triangles is called similarity ratio. So let's see what does this definition tells us. Let's say you have two triangles, something like this, and another one like this one. So let's say these two triangles are similar. This is so vertex A, B, C, and this one is A prime, B prime, and C prime. So if these two triangles are similar, then the corresponding sides are proportional. In other words, A prime, B prime over AB, this ratio is equal to A prime, C prime over AC, and that is equal to B prime, C prime over BC. Okay, now this number that you get here, this number over here, which is obtained by dividing two corresponding sides, is called similarity ratio of these two triangles. Okay, so this number is called similarity ratio of these two triangles. So just divide the corresponding sides, and whatever number you get, that is called similarity ratio. As an example, you see here two similar triangles. And I want to know what is the similarity ratio between these two triangles. So just all you have to do here is to divide two corresponding sides, and that will be your similarity ratio. So for example, if I take DE, side DE, this one, from this triangle corresponds to AB from the smaller triangle. So if I divide these two numbers, that ratio is the similarity ratio. So in this case, it is 10 divided by 5. Okay, so 10 comes from DE and 5 comes from AB. 10 over 5, which is equal to 2. And that is called the similarity ratio of these two triangles. Just notice here that if you divide any other corresponding sides, you will get the same value. If you divide DF by AC, 8 divided by 4 is 2, the same number. If you divide EF by BC, 6 divided by 3, you will get the same value. So this value is called similarity ratio between these two triangles. Just one thing that you should pay attention to here is that if I start with this triangle and divide AB by DE, I'll get the number 1 over 2, right? So because it is 5 divided by 10 is 1 over 2. And if I divide AC by DB, I get the same number, 1 over 2. BC divided by EF, 3 divided by 6, which is 1 over 2. So basically, similarity ratio comes in two ways. One way is this number 2, and the other way is the reciprocal of this number. Okay, so there is absolutely no difference between these two numbers. The only thing is that which one you have to take on the top and which triangle you want to take down to take the ratios. Okay, so in this case, I took this triangle over this triangle, so the answer that I got was 2. Now, if you like, you can take this triangle and divide it by this triangle, and the answer that you will get is 1 over 2. So there's absolutely no difference. Any way that you can that you like, you can take, and that is perfectly okay. So the similarity ratio between these two triangles is 2 or 1 over 2. There's absolutely no difference here. It doesn't make any difference for us. So now here is the gist of the lecture, which is a theorem. that tells us how we can compare the perimeters and areas of two similar triangles. So let's just read this theorem together. If the similarity ratio of two triangles is A over B, is this number, then the ratio of their perimeters is A over B, so the same number. Okay, so the similarity ratio and the perimeter ratios are the same number. And the ratio of their areas is A over B squared. So that's the only difference that we have here. For the ratio of areas, we should square the similarity ratio. So let's explore this theorem a little bit more in detail. Let's see, what does it say? Imagine you have two triangles, two similar triangles. So one of them, let's say, looks like this. I like to call this vertex A, this one B, and this one C. And then I have another triangle which is similar to this one, maybe a little bit bigger, maybe like this one. So let's call this one A prime, this one B prime, and this one C prime. So as you see, A prime B prime corresponds to AB, B prime C prime corresponds to BC, and A prime C prime corresponds to AC from the other triangle. So let's say these two triangles are similar. All right. So let's give them some measures. Let's say AB is I don't know. Let's say this one is 4 centimeters, whatever the unit is, and let's say A prime B prime is 12 units. So let's see what is the similarity ratio of these two triangles. Well, since these two triangles are similar, all I have to do here is to just divide the corresponding sides, and that will be my similarity ratio. So AB corresponds to A prime B prime. So similarity ratio in this case is similarity ratio. So SR stands for similarity ratio, equals AB over A prime B prime. So AB is 4, and A prime B prime is 12. If you simplify this, you'll get 1 over 3. So this is the similarity ratio between these two triangles. Just notice here, I decided to take AB over A prime B prime. So if you like, you can take A prime B prime over AB, and your answer will be the reciprocal of this number, which is 3 in this case. Okay, I got the similarity ratio between these two triangles, which is 1 over 3. So according to this theorem, if I take the perimeter ratios, if I find the perimeter of this triangle, remember perimeter means adding all the sides. So you should add AB to BC and to AC. That will be the perimeter of this triangle. And if I find the perimeter of this triangle by adding up the sides here, and if I divide this perimeter of this triangle by the perimeter of this triangle, the answer will be the same number as similarity ratio. So that's what this theorem tells us. If the similarity ratio is A over B, then the perimeter ratio is the same number, A over B. Moreover, if I find the area of this triangle, and if I find the area of this other triangle, and if I divide these two numbers, the answer is the square of this number, right? That's what it says here, A over B squared. So let me write down here, perimeter ratio. Perimeter ratio is the same number, 1 over 3, and the area ratio is 1 over 3 squared, which is 1 over 9. So if I find the area of this one and the area of this one and divide them, the answer will be 1 over 9. That's all that this theorem tells us. Let's see how we can apply this theorem in some questions. Example, given that triangle RST is similar to triangle UVW, so these two triangles, they are similar. Perimeter of RST is given to be 36, and its area is given to be 48. So perimeter and area of this triangle is given, and the question says find the perimeter and area of the other triangle. Okay, so let's say perimeter of this triangle RST is given, it is 36, and its area is given to be 48. And you want to find the perimeter and area of the other triangle. Okay, so let's see how. Let's find perimeter first. First, perimeter. Let's find perimeter of triangle UVW. First of all, what is the similarity ratio of these two triangles, right? Look, RS corresponds to UV. Okay, so what is the similarity ratio? Just divide 16 by 20, and that will be the similarity ratio, right? So let's write that one. Similarity ratio equals RS over UV, and that is 16 over 20. If you simplify this, you will get 4 over 5. So that's the similarity ratio of these two triangles. But what is the perimeter ratio? Okay, according to the previous theorem, the perimeter ratio is the same number. So if I divide perimeter of this triangle by the perimeter of this triangle, the answer is the same number, 4 over 5, right? So let's do that. So perimeter of triangle RST, so that means, this means perimeter of the triangle RST divided by perimeter of UVW is equal to the same number, the same thing here, is equal to the similarity ratio, which is 4 over 5. But we know what is perimeter of RST. It's given, it's 36. So let's just replace it here and then find this value by a cross product. So perimeter of RST is given to be 36 over perimeter of UVW equals 4 divided by 5. So now here all you have to do is just a cross product. So 4 times perimeter of UVW equals 5 times 36. Okay, so perimeter of UVW equals, so divide both sides by number 4, and the answer becomes 45. So that's the perimeter of triangle UVW. Let's find area. So area is the same procedure. So the same method that we used here for perimeter, we can apply it for area. So what is the area, the ratio of area of RST over area of UVW? So remember the previous theorem tells us that the ratio of areas is the square of the similarity ratio. So I have to square this number. 4 over 5 to power 2, which is 16 over 25. And yet again, I have the area of RST, so just replace the area of RST here, and then again, a cross product will give us the area of UVW. So area of RST is given to be 48 over area of UVW equals 16 over 25. And now by just doing a cross product, you will get the answer. Area of UVW equals 75. And that is the area of this bigger triangle. So this example is a very important example. Just go over it one more time and try to solve it for yourself. And I try in the next videos, I try to give some more examples like this one and solve them for you. So next example says, if the similarity ratio between two triangles is 2 over 3, what is the ratio of their perimeter and what is the ratio of their areas? So similarity ratio is given, it's 2 over 3. And the question says, what is the ratio of their perimeter? Well, that one is easy, right? Because of the theorem. If the similarity ratio is 2 over 3, then the perimeter ratio is, so perimeter ratio is equal to the same number, similarity ratio, 2 over 3. So that's it. What is the area ratio? Well, area ratio is the square of similarity ratio. So I have to square 2 over 3. So I should take it to power 2. So the answer is 4 over 9. So the area ratio is 4 over 9. As simple as that. Next example. If the ratio of areas of two triangles is 16 over 25, what is the similarity ratio of these triangles? So this time, the ratio of areas is given, and question says, what is the similarity ratio? Okay, so remember, the ratio of areas is the square of similarity ratio. So if you have the ratio of areas, and you want to find the similarity ratio, you should take the square root of this number. Okay, so just remember the relation between them. So similarity ratio equals square root of this number, which is 4 over 5. So the similarity ratio of these two triangles must have been 4 over 5 so that the area ratio becomes 16 over 25. And that's it for this video. In the next video, I try to give you some more examples and exercises on this topic.